Hello Year 10, welcome to today's lesson on spheres. You've got 2 PowerPoints on spheres for this week. The first one I'm going to be looking at volume. So if you could rule off please where you got to last lesson, write the title, which is volume of spheres, and the date, that'd be brilliant. And then just pause the video as you have a go at the do now task. Right, very good, let's have a quick look. So you should remember from last week's lessons that this is our formula for the surface area of a cone. So we should now know that this pi times radius times slant height represents the curved face, and the pi r squared represents the surface area of the base, which is always a circle. All you have to do is use your calculator. So you could do pi times radius, which is 3, times slant height, which is 6, and then put a plus, and then pi times radius squared, and then we get our answer. And if we round to 1 decimal place, we get 84.8 centimetres squared. Right, okay, so today's criteria is bronze to be able to calculate the volume of a sphere, silver to be able to calculate the volume of a hemisphere, and we'll look at what that means shortly, and then gold is to apply knowledge to problem solving questions, so differing contexts where it's not just as straightforward as here's a sphere, find the volume. So we'll look at those as well a little bit later on. So first things first, what is a sphere? I'm sure most of you know. You see them lots and lots in everyday life. We'll have a look at some examples in a moment. But if you're trying to find the volume of a sphere, you need the radius. This isn't like trying to find the circumference of a circle where you can use the radius or the diameter. We have to have the radius in this instance, and that is your formula. Now I know it looks like quite a complex one, but it's something we're going to use really often. We'll look back at it lots once you're back in school, so don't worry about it. It's something we'll look at again together. If you could please just write that formula down, and then just whilst you're doing that, here are some examples of where we see spheres in everyday life. So I know we've got lots of sports fans, particularly my groups in 10x4 and 10y4, lots of football fans, so you'll see spheres, football, pool, cricket, all sorts of things. If you like doing exercise with an exercise ball, you'll see it then. Lots of things to do with decorations, and of course marbles. So we see spheres a lot. So we're going to look at an example together. I would just like you to look at what I'm doing, have your calculator ready. We'll be using those today, and do the work on your calculator as we go through it on the PowerPoint, just so you can see how things work. So we're going to start by finding the volume of this sphere. Now we can see it's a really straightforward question. You've got your radius of 9 centimetres. We know what the formula is. It's in the top right here. So all I've done is I've opened it out, because we should know from our Key Stage 3 work and from our previous work actually on equations that when you've got mathematical symbols, notation and letters, but actually what goes between all of those, unless it's specified differently, is a multiplication. So that's actually what we're doing. So the only thing we really need to find that's not already given for the equation is the radius, and we need to cube it. Well, the radius is here, it's 9. So that's all we have to substitute in. So what I would like you to do, please, is to press the fraction button on your calculator and put 4/3, multiply by pi. You usually have to press the shift button and the pi button at the bottom of your calculator, and then multiply by 9 cubed. And what you should get is an answer that probably looks like this first. So when you ask for your answer in terms of pi, you get a numerical value and the pi symbol. So it's 972 pi. So that's your answer in terms of pi. We should then get, if we do our answer to 1 decimal place, you should get 3053.6. So remember, when we're rounding to 1 decimal place, you have to look at the second decimal number. And in the cases of this question, your second decimal number is a 2, so you should all have 3053.62. Well, we know the rules of rounding. 5 and above you round up, and 4 and below you leave it alone. So that 6 stays as it is. If you could please just pause the video and copy this example down in your book exactly as it is, that would be brilliant. Thank you. Right, good. Next one. So I'll have a look at another example together. Now it looks really similar, but there is one important difference. We can see here that actually what we're given is the diameter. And remember, in maths, they're not trying to make it really easy, particularly if we're looking at those higher level questions. So that distance there, that 12 centimetres, is the same as the diameter here that cuts through the centre of the circle from circumference to circumference. Now that diameter isn't really that helpful, except for one thing. We know that if we half it, we get the radius. So we now know the radius of this sphere is 6. And again, all we have to do is substitute that value of 6 into the correct place in the formula. So if we do that, that's the important line of working out. If you input that into your calculator, please do that now, you'll get your answer in terms of pi first. Usually that's what happens. And you'll get 288 pi. If you now press your SD button, you get an answer of 904.77. But again, we want our answer to one decimal place, so that second 7 after the decimal point rounds the first 7 up to an 8. If you struggle with your rounding, it's something we're going to use a lot in this topic, so you get some practice. There's also lots of things on Hegarty you can look at to help you with rounding. But what I would always do is just show your working out, because as I've said to my groups before, and I'm sure other groups have been told before, show your stages of working, because that gets you a lot of credit, even if your answer at the end isn't always spot on. Brilliant. Please pause the video and just copy this example down. Lovely. Right, here are some practice examples for you. So you've got 6 standard examples here. All of the units at the end will be centimetres cubed. So just be mindful of when you're given the radius and the diameter. And then you've just got 2 real life examples of where you'd see a sphere and can you find the volume of those spheres as well. Now this one's a little bit different. It says round to 3 significant figures. So just be careful with that as well. If you could please just pause the video as you answer these questions, that would be brilliant. Brilliant. Right, we're now going to fly through the answers. Have your marking pen ready. Okay, first one. You should have, to one decimal place, 523.6 centimetres cubed. For B, you should have 904.8 centimetres cubed. And for C, 1,436.8 centimetres cubed. Now, if we look at D, there's your answer. 4,188.8 centimetres cubed. If you're looking at your answer thinking, mine's double the size of that, mine looks really big, my answer, it's because you've not halved the diameter. You've used the diameter rather than the radius, and the radius would be 10. So if you think you've made that mistake, you might want to pause the video now and just go back and have a look at E and F again, because you've probably made the same mistake there. If not, we can just carry on. 7,238.2 centimetres cubed and 523.6 centimetres cubed. Brilliant. We'll now look at these ones here. So these questions are interesting because we're rounding to 3 significant figures. But again, show your working out. Now, your answer should be 180 centimetres cubed. If you don't have that, it's probably because you're not rounded properly. So if you can just re-put the sum, or the formula of the question into your calculator, so 4/3 times pi times 3.5 cubed. And what you actually get is 179.5 and then lots of numbers after. But we want to round our answer to 3 significant figures. Now our third significant figure in the answer is the 9. It's 1, 7 and the 9 is the third significant figure. Now that 5, that fourth significant figure after the decimal point, well, the rules of rounding are the same. That 5 rounds that 9 up to a 10, which has a knock-on effect and gives us an answer of 180. The same rules apply here, so you should get 4,850. Now, if you think your answer is not quite right, it's again maybe because you haven't used the radius. So the radius will be half of this, it'll be 10.5. And then initially for here, if you put the equation in, you'll have 4,849 points and then lots of numbers. Now your third significant figure there on your calculator is that second 4. So we need to see if that changes or stays the same. Well, the fourth significant figure is the 9, and that 9 rounds that 4 up to a 5, and the 9 becomes a 0, so we get 4,850 centimetres cubed. Well done. Right, this question is a little bit different, it's a little bit more complicated, particularly if you're a visual learner, because there is no diagram to help you. So you're asked to find the volume of a sphere of radius 5 centimetres. Now you could sketch this if looking at something makes your life easier, or alternatively, if you're comfortable with the formula, you don't need the picture, you just apply the same rules. So you're told in the question, we have a radius of 5 centimetres. Well, let's just substitute that in here, and we get our answer there, okay? Then if we press our equals button, in terms of pi, you will get a fraction, okay, over 3 in terms of pi. It's not a problem at all. And if you press your SD button, and again we're rounding to 1 decimal place here, you get 523.6, and it's a 0.6 because your first 2 decimal numbers are a 5 and a 9, and the 9 rounds the 5 up to a 6. Okay, we're going to look at these together as well. I just want you to put your pens down for me for now. I don't want you to copy anything until the end. We're just going to look at how this works. Now this is what we call a hemisphere. Now you can see that quite clearly is half of a sphere. So you would expect the volume of a hemisphere to be half the volume of a sphere that has the same radius. Now we know here, because we've used it, that's the formula to find the volume of a sphere. Well, this here is the formula to find the volume of a hemisphere, which is half of a sphere. And you'll notice the only thing that's changed is the fraction element. We've got 4/3 and 2/3. Well, if we look at what 4/3 means, it's actually 4 lots of 1/3, because if we add those together, we get 4/3. But we're looking for a hemisphere, which is half of that, so we have half of the fraction, which is actually 2/3. So could you please write that formula down and really be clear that it's for a hemisphere? Now, if you're worrying about having two different formulas, an alternative is you can still use this formula for hemisphere, but then you will just divide your answer by 2 at the end. So either of those is fine. Please write down whichever one you want to use and just pause the video as you do this. Right, brilliant, good. We're going to go forward using this formula here. But just remember, and it might be worth checking, well, what if I use the formula for a sphere and half it? You can see you get the same answer. So let's just open out our formula, because again, we know that those fractions, symbols, all these numbers together, when there's nothing between them, when they're just punched together, we know it's a multiplication between, and then all we need to add is the radius, which is 8. That's what we would input into our calculator. And then we get an answer in terms of pi, which is 1024 over 3 pi, which is not a problem. And then you get an answer that looks like this. That's perfect. You've done really well if you've got to this point. But we're asked here to give our answer to 3 significant figures. So let's have a look. Well, here's our first significant figure. Here's our second significant figure. And here's our third. So this is the one that might change, the 7 might change, and the 2 is in charge of if that happens or not. Well, the rules of rounding of 5 or above round up, 4 or below stays the same. Well, it's a 2, so it keeps the 7 the same, but where that 2 once was, you put a 0, and everything after will become zeros, but you don't just need to write 0.000 because it doesn't have any value, so we would just write this. If you struggle with that idea, if you've done all of this beforehand, you're going to get credit for that, okay? But we're just going to keep looking at these different ways of rounding as we work through. Right, next one here, we're going to go through this together. Please have your calculator ready and go through the answer, go through the working out as I do it, just to make sure we're all clear and understand. So again, we know that we're just opening out the formula, and we've got multiplications there between the fraction, the pi, and the radius and the cubed. Well, this time the radius is 7. So what we're putting into our calculator is this here. And again, when we press our equal sign, we get that. Don't worry that it's a fraction, it's unusual, it's because we're getting funny decimal answers at the end. Now here, we want to round our answer to 1 decimal place. So press the SD button on your calculator, and you will get 718.377. So to 1 decimal place, it'd be 718.4. If you can just pause the video and copy this down exactly, that would be brilliant, thank you. Good, well done. Here are some practice questions for you. So we've got 3 questions about spheres, but without a diagram for you to work through, round to 1 decimal place, and then 3 questions about hemispheres. Again, for all of these, we're trying to find the volume, rounded to 1 decimal place. Please pause the video as you work through these and show your steps of working out. Okay, excellent. Here are all the answers we should have. So 113.1 centimetres cubed, 904.8 centimetres cubed, and 4,188.8 centimetres cubed. Just make sure here that you've changed that to a 10. And then here we should have 16,755.2 centimetres cubed, 3,619.1 centimetres cubed, and 56,548.7 centimetres cubed. Please make sure you've marked your work. If you made any errors, please put the corrections in and just have a look back through them. Excellent. Right, what we're going to have a look at now are a couple of more complicated questions. These are really higher tier questions, looking at our top of our grade 5 here. So if you don't have to work through these two, If you don't feel comfortable working with these, if you think at the moment without your teacher in front of you they're a bit too complicated, don't worry about it. Just go through the video and go to the last slide and look at what you have to do next. But if you want to work through these more challenging questions, just let the video run its course, please. So here we have a container containing tennis balls. Brilliant, we can see it there. It's created from a cylinder. So a cylinder we looked at in chapter 13 or 14, I think, and a hemisphere on top. And it says, calculate the volume of the container and round your answer to 2 decimal places. Now what I'm going to do now is I'm going to just ask you to pause the video for a moment and just take 30 seconds to think about maybe what you think you have to do. Good, well done. If you're sat there thinking, I've no idea, miss, what to do, I'll make it easier for you. Sorry, that should say part 2 hemisphere. I've broken down the working out for you. So we're trying to find the total volume of the whole container, and we've got a cylinder and a hemisphere. Now that you have that information, again, if you feel comfortable and confident, please pause the video and see if you can now find the total volume. Right, perfect. The next stage, if you're still unsure, and hopefully you've looked back in your exercise book and you found the formula for the volume of a cylinder, and you've been able to work through and put the right information in, you would then get the volume of your cylinder. Excellent. Now hemisphere, we've looked at loads today. Substitute the information in and we get this. Now what we're trying to find is the total volume. So we've got to add those 2 values together, and you're probably thinking, well, miss, they're really long decimals or they're never-ending decimals. I can't put those back into my calculator. Well, actually, all you have to do is put this calculation in, and then in your calculator put a plus symbol, and then this calculation, and it will do that hard work for you. So just have a go at that for me, please. Pause the video whilst you do that. Brilliant. And then you should get a total volume of this. And we know we're pretty much right, because 226 add 16 gets us to 242, and then it's just our decimal bits being added together as well. Brilliant. Right, our last real gold level question here, level 5 question. A solid sphere, here it is, fits exactly into an open box. Okay, there we go. The box is a cube with side length of 25 centimetres. Just have a think about what you now know about the dimensions of this box. If it's a cube of side length 25, we should know that means all of the dimensions are 25. That's really helpful. Once the sphere is in the box, how much water can be poured into the box before it spills over? Now what I've done for you here is I've broken this question down to 2 parts. We've got volume of the box and volume of the sphere. Now those 2 things on their own won't get you to the final answer, but they'll get you lots of credit. So please pause the video as you try and calculate the volume of the box and the volume of the sphere. Brilliant. Right, again, if you're unsure, here are the formulae you should be using. So the volume of the box, length times width times height, because you know that's what you do for a cuboid. And here's how we find the volume of a sphere. Now that you've maybe got those to help you, please now find the volume of those 2 objects. Please pause the video as you do this. Excellent. So again, the box, we know it's a cube, so we're doing 25 times 25 times 25. So we should have that as our answer, which is brilliant. That would get us lots of credits. Then we can find the volume of the cylinder, of the sphere. Now where we might trip up here is, if you've already looked at this and you've thought, hang on a minute, I've put 25, remember we need the radius. If the sphere fits exactly in, if that distance there is 25, it must mean that the distance there is 25 across our sphere. But we want the radius, and half of 25 is 12.5. Now if you've not put 12.5, go back and do that now, have a quick go at it, pause the video and see what you get. For those of you who are happy, you should have got an answer that looks a little bit like this, okay? And again, you're probably thinking, well, miss, how on earth do I put that number back into my calculator? Because we know that when we're trying to find how much water can be poured in once the sphere is in, we're trying to find the difference. So do subtraction. Now, once you have this answer in your calculator, don't delete it, don't press the on-off button, leave it there. What I want you to type into your calculator is this value. Okay, so type that value into your calculator, press the subtraction button, and then on the bottom row of your calculator there is an ANS button. Now press that. So in your calculator you'll have 15,625 subtract ANS, and that ANS just means the last answer you got, and it's this one. and you should press equals, and then you get 7,443. Well, we know that's about right, because 15,000 take away 8,000 is 7,000, so we know we're on the right track, so that's probably what we should have. If you don't have this, please jot it down, maybe even write the teach question out, maybe even do a sketch, because lots of you should be getting 4s and 5s at the end of your year 11, and these are the sorts of questions that will get us lots of marks to get us there. Right, the last thing you need to do volume of spheres is just to complete task 580 on Hegarty Maths. Only one to do for the volume of spheres. Really well done. And I'll see you, not see you, probably you'll hear me in your next lesson, you lucky lot.